Hi guys, this is Abhi from Engineering Master. Welcome to the another episode of Engineering Master. In this video, we are discussing about diesel generator. This is a diesel generator specification from one of the best engineering consultant in the world. In this video, we will learn to design the diesel generator for a project. We'll try to go into deep. Because of that, the video may be a little bit lengthier. Don't skip, please watch. What is diesel generator? A diesel generator or a diesel genset is a combination of diesel engine with electric generator to generate electrical energy. Generator produce electrical energy from mechanical energy. This is a function of a generator. If you look at the energy conversion inside a generator, we can see the chemical energy of fuel or diesel. Diesel has a chemical energy. It is converted into heat energy because of combustion. So the diesel is burned inside the engine and the chemical energy of diesel is converted into heat energy. This heat energy is used to rotate the piston and crankshaft. So the heat energy will be converted into mechanical energy. Mechanical energy is used to rotate the alternator. Because of that, mechanical energy will be converted into electrical energy. This is the energy conversion process inside a generator. The chemical energy of fuel ultimately is converted to electrical energy. The generator rating is expressed in kVA, kilovolt ampere. kVA equal to kilowatt divided by power factor. For a diesel generator, the power factor is considered as 0.8. Almost all the manufacturers in the world is making the generator with the power factor 0.8. For all DG calculations, please consider power factor as 0.8. Let's learn to design a diesel generator for a project. This is our scenario. Design a diesel generator for the residential building with the maximum demand of 300 kVA. The area has frequent power failures lasting up to 5 hours. Our building has a maximum demand of 300 kVA and our building is situated in an area where the power cuts are common or the frequency of power failure is more. Let's look into this problem. We know our kilowatt maximum demand equal to 300. So we are converting maximum demand into kVA. kVA equal to kilowatt divided by power factor. So power factor for DG calculation is 0.8. The maximum demand in kVA equal to 300 division 0.8. That will be 375 kVA. A generator is ideally set to run 80% of the capacity for continuous usage. Or we can say generator has the most efficiency while running with 80% of the load. In that scenario, generator rating equal to maximum demand in kVA divided by 0.8. 0.8 is 80%. The 80% of the installed generator capacity should be equal to the maximum demand in kVA. That is the logic. In that scenario, what is the answer? The answer is 375 divided by 0.8. That is 468.75 kVA. So no manufacturer is making generator with 468.75. So we'll go for the next available rating. The next available generator capacity is 500 kVA. So our generator capacity is 500 kVA. We all know our project with this capacity will be 3-phase. So the building is in 3-phase. The line voltage, what is the line voltage? This line voltage may be slightly vary from country to country, region to region. You have to consider your line voltage. My line voltage is 415 volt. Frequency. The frequency of power supply is 50 Hz. Hertz is the unit of frequency. 1 Hertz means 1 cycle per second. You can imagine the sine wave, right? So 1 sine wave completion is 1 cycle. 1 cycle per second is 1 Hertz. Around 43 countries in the world are using 60 Hz as frequency, including United States of America. But India and other countries are using 50 Hz as their frequency. My frequency is 50 Hz only. So our specification will be 500 kVA, 3-phase, 415 volt, 50 Hz. In this way, step by step, we are elaborating our design and specification. So spec is 500 kVA, 3-phase, 415 volt, 50 Hz. If the frequency of power supply is 50 Hz, generator RPM will be 1500. If the frequency is 60 Hz, the preferred RPM is 1800. So this is the equation. RPM equal to Hertz or frequency into 120 divided by number of poles. we prefer 4-pole generators. It has more benefits than 2-pole generators, including compact size, lower weight, better efficiency, higher inertia, shorter delivery time, lower running cost and simplified maintenance. As a number of poles we will consider as 4. In that scenario, the equation will be RPM equal to 50 into 120 divided by 4. The answer will be 1500 RPM. So, our RPM with 50 Hz is 1500. So, this 1500 or 1800 RPM generators are ideal for static installation for daily prime power as well as for regular standby generator or backup generator. This 1500 RPM machine is a slower running water cooled design. So it will be less stress compared to 3000 or 3600 RPM air cooled machine. This will make it as a best option as your main power source. This 1500 RPM machines can generate higher kVA than 3000 or 3600 RPM generators, which makes it ideal solution to power larger appliances for longer periods. So our specs elaborated to 500 kVA, 3-phase, 415 volt, 50 Hz, 1500 RPM. Next one is purpose. Based on the purpose, the generator is divided into two. One is prime generator or as a primary power source. Second one is backup or standby generator or as a backup power source. What is prime generator? These prime generators are used as a primary power source for your purpose. For example, it is utilized in a situation where the primary power source or building power source is not available. You have to depend on generator for power source. Example, outdoor festivals or large infrastructure construction works. In these scenarios, the utility power or the supply from the power supply provider will not be available nearby. So we have to use generator as a prime power source. The second one is standby power source or standby generator. This is normally installed in a stationary location as a backup power in case of power failures. It is used as a backup power in case of power failures or power outage. You can see generator installed in a stationary location and it is used as a backup power source for these villas. Almost all the generators are suitable for both the purpose. It can be used as a prime generator or it can be used as a standby generator. In that scenarios, the standby rating will be typically higher than the prime rating. For example, a generator with prime rating of 100 kVA, it is designed to be able to run at 100% of capacity, that is 100 kVA, or as a primary power source. But it can be overloaded up to, we can say, 120 kVA for 1 hour in any 12-hour period. Basically, the standby rating of a generator will be higher than the prime rating of a generator. Almost all the generators can be overloaded to its standby rating for some time periods. So our core generator spec elaborated to 500 kVA, 3-phase, 415 volt, 50 Hz, 1500 RPM, prime duty generator. We need a prime duty generator because in our project scenario, the power outage is common. So we are selecting generator prime rating as 500 kVA or prime duty generator as 500 kVA. Then we have to further elaborate our specification. So we will look at the energy conversion cycles. The first is chemical energy of fuel or diesel. It is converting into heat energy. We will try to learn about the generator parts or generator accessories based on this energy conversion. So we will learn what are the parts involving for converting chemical energy of fuel into heat energy. For this we need fuel, right? Then we need air or oxygen. Oxygen is the gas which helps to burn, right? Without oxygen, the combustion will not happen. So let's look into the parts associated with it. If you look at the fuel flow in a typical generator, it will be like this. The fuel from the fuel tank, it is going to fuel water separator. Then it is going to the fuel filter. Then fuel pump governor shut-off valve assembly will be there. Then CRDI, common rail direct injection. Then it is going to the injector. Through the injector, it is going to inside the cylinder and it will be burnt. So we will look at one by one. The first one is fuel tank. Commonly two types of fuel tanks are used. The first one is base tank. If the DG is portable, then base tank is used. The tank will be below the DG itself. So you can see from the picture, it's a Cummins DG. The tank is below the DG. This type of tank is called base tank. If the DG is stationary or fixed, then we will add a separate small tank. It is called day tank. These are the pictures of day tank. For a fixed DG in nearby location, there will be a tank placed and associated fuel filling systems. The fuel is coming to the entrance of the building in a specified area. With the help of piping, the tank can be filled. This type of tank is called day tank. What should be the ideal fuel tank capacity of a building? The fuel tank capacity depends on the authority regulations. In normal scenarios for residential purpose, minimum 4 to 8 hours backup is recommended. For commercial purpose, 8 to 12 hours backup is preferable. For hospitals, the backup time may be increased to 72 hours. Based on the purpose and authority regulation, we have to choose the backup time. My area is prone to power outage, so I am selecting the DG with 8 hours backup. What is our generator size? Generator size is 500 kVA, right? If you look at the catalog of a prominent DG manufacturer, Caterpillar, this is an excerpt from a 500 kVA DG catalog from Caterpillar. You can see fuel consumption is specified. With 100% load with fan, the fuel consumed is 108.8 liter per hour. Our DG has 8 hours backup, right? What will be the diesel consumption for 8 hours at 100% load? That will be equal to 108.8 diesel consumption per hour into number of hours, 8. So the answer will be 870.4 liter. I am adding 15% spare. So diesel tank storage sizing will be 870 into 1.15, approximately equal to 1000 liters. So our diesel tank capacity shall be approximately equal to 1000 liters for 8-hour backup at 100% load. So from the fuel tank, the diesel is going to fuel water separator and fuel filter. In some generators, fuel water separator and fuel filter found together. In other generators, it is found as two separate components. Fuel water separator, what it is doing? It will separate water from diesel. So the fuel water separator separates water from diesel and send only pure fuel to the engine. This separator needs regular inspection. The trapped water has to be removed frequently. The second one is fuel filter. As the name suggests, it will remove impurities from diesel. These impurities may be harmful for the cylinder and pistons. This filter will remove impurities from the diesel. Next part is fuel pump, governor and shut-off valve assembly. The fuel pump shall be PT type, pressure timing type. So it will ensure the pressure as well as timing. It is a gear pump. There is no motor attached to the fuel pump. It is attached to the crankshaft or it runs based on the crankshaft movement. The another one, the bottom portion you can see the governor. The top portion you can see shut-off valve. The purpose of the fuel pump is to pull the diesel from the tank. The fuel pump pull diesel from the tank. Governor controls the fuel flow. Based on the output from the sensors, governor ensures engine is running on steady RPM regardless of load on DG. Whether it's no load or full load, governor ensures steady RPM for DG by controlling the fuel flow. Shutdown valve or shut-off valve. It performs like NRV, non-return valve. It separates fuel from injector and pump when generator is off. When the DG is off, the valve will be off. That's how it separates fuel from injector and pump and prevents the emptying of diesel from injector. Because of the shutdown of this valve, there will be always diesel in every part of the system. Then another one is CRDI, Common Rail Direct Injection. The fuel is stored into the high pressure common rail. By the action of the pump, the fuel will be stored in high pressure in a common rail. From the common rail, the fuel is distributed into different parts of the engine or different cylinders. We can say it acts like a distribution board. It receives the fuel and distributes into the different parts of the engine. The next part is injector. The fuel injector. What is it doing? It is atomized fuel into droplets. It will divide the fuel into small droplets and inject into the combustion chamber. The function of the fuel injector is to divide the fuel into small droplets and inject into the combustion chamber. In the combustion chamber, the fuel will burn in the presence of oxygen. So this is the fuel cycle of a generator. The diesel from fuel tank will be moved into the different filters, fuel filter and fuel water separators, and to the fuel pump, then to CRDI, through injector, it is going to the cylinder. So this is the fuel cycle. So our DG specification will be 500 kVA, 3-phase, 415 volt, 50 Hz, 1500 RPM, prime duty DG. Then we are writing our fuel cycle parts. The DG set shall be inclusive but not limited to the following standard accessories. Fuel tank, drip tray for fuel tank. Drip tray you know, right? Some dripping while filling of the diesel, it will collect in the drip tray. Fuel hoses we know. Fuel filter, fuel pump, governor, CRDI, injector. I am writing, this is my DG specification. My DG should have these components from the fuel part. As we said, for the fuel to burn, we need oxygen. Oxygen is drawn from the atmosphere. Before putting the air into the combustion chamber, it is gone through air filter. Air filter is used to filter the impurities, dust, pollen, etc. from the air, and only the pure air is supplied to the compression. So every generator has 3 filters. One is fuel filter, second one air filter, the third one is lube filter that we will discuss later in this video. Another important part for air intake is turbocharger. What is turbocharger? Turbocharger uses exhaust gas from the engine. So there will be an exhaust smoke and gases from the engine, right? So turbocharger use this gas to spin a turbine and compress the air. So using these exhaust gases, turbocharger will spin a turbine and compress the air. This compressed air increases the amount of oxygen in the air. So more fuel can be added to the engine and it will increase the power and fuel efficiency of the engines. So along with the specification, I am adding air filter and turbochargers. The next part is heat energy of the fuel is converted into mechanical energy. So cylinder, piston, crankshaft and flywheels. These 4 parts mainly used for this process. We know the combustion happens inside the cylinder, right? Inside the cylinder there will be a piston also. The piston will convert the heat energy into mechanical energy. The piston will move to and fro. This crankshaft is associated with the piston. Crankshaft will convert linear motion of the piston to the rotatory motion. A flywheel and flywheel housing is attached to the crankshaft. So I am adding flywheel and flywheel housing to the specification. As we know, generator has too many rotating parts or moving parts. There will be some heat produced due to the friction, and this moving part is subject to wear and tear. To reduce the wear and tear and remove the heat produced due to the friction, we will use lube oil or lubricating oil. So these are the advantages of lubricating oils. It reduces wear and heat, it removes heat, it lubricates moving parts, it reduces friction, it helps with decontamination, it helps to remove the dirt and deposit from engine, it seals pistons and it prevents corrosion. This is a typical flow diagram for lubricating oil inside a diesel generator. Oil is collected in oil sump. From the oil sump, we are using lube oil pump, lubricating oil pump. Then through the oil cooler, it is going to filter, header, filter and bypass assembly. From there, it is going to the destination, wherever it is required. This is our oil pump. It is also a gear pump attached to the crankshaft. It runs based on the movement of crankshaft. Then oil cooler. The oil coming back from the engine will be very hot. So it passed through an oil cooler to reduce the temperature. So the function of the oil cooler is to reduce the temperature of the oil. Then oil filter, header and filter. This is the third filter in diesel generator. Fuel filter, air filter as well as lube filter used in the diesel generator. You can see there is a header for the oil. In the header, filter is installed. For the generator, we need a radiator and fan. You may have seen this. So the function of radiator and fan is to remove the heat from the engine coolant and prevent the engine from overheating. Because of the combustion happens in the combustion chamber, there will be a heat produced. The engine coolant is used to remove the heat from the engine. The function of radiator and fan is to remove the heat from the coolant. Then due to the working of generator, there will be an excessive noise produced. Silencer is used to reduce this noise. Silencer is attached to a pipe, this is called flue pipe, and an expansion bellow is used to couple the silencer to the engine. Apart from the silencer, if the DG is installed outside, then there is an acoustic enclosure used to reduce the noise levels. If the DG is inside the room or inside the building, then the room needs to be treated acoustically. The special acoustic treatment for the room is recommended in case of DGs installed in the room. So we are adding this component to the specification. lube oil pump, lube oil cooler, lube oil filters, and bypass filter. Then radiator with fan, silencer with expansion bellow and flue pipe, acoustic enclosures. Another important component in DG is self-motor or starter motor. A self-motor or starter motor is used to rotate the crank of an engine at the starting, at the beginning of combustion process. For the engine to operate its own, self-motor or starter motor is used to rotate the crank. Self-motor is a DC motor. For the motor to power, we need some batteries, we need some power source. So we will use some batteries as the power source. We know battery needs to be charged regularly. While the operation, a dynamo is used to charge the batteries. So when the generator is in operation, a small dynamo will keep charging these batteries. In standby generators, it won't be operated for a long time, right? The frequency of operation will be less. So in that scenario, there will be a separate battery chargers in the control panel or attached to the generator. This will keep charging the battery when generator is in standby mode or it is not in use frequently. Another one is alternator. Alternator is used to convert mechanical energy into electrical energy. The DG alternator should be self-excited, self-regulated, brushless and continuously rating for kV at 0.8 power factor. 3-phase 415 volt, 3-phase line voltage is 415 volt. 50 cycle per second, that is frequency. 4-wire system shall be provided with the static excitation unit. So basically we need a brushless generator. We were using generator with brushes. This brusher is subject to wear and tear and it may cause spark also. So nowadays brushless generators are used. Another one is control panel. Control panels is a visual display of different parameters. You can see line voltage, current, frequency and other parameters on the control panel. You can see the load also. Every DG, there will be a control panel attached to it. So I am adding this component to our specifications. Starter motor, batteries, battery chargers, brushless alternator, generator control panel. For the load of 300 kilowatt building, our DG specification is like this. This generator is a vast topic, right? Every component is a topic for 1 hour video. I think you got a fair idea about generator and generator specification and the designing of generator for a project. See you in the next video. Bye bye.